Welcome to the chapter 2 of SystemVerilog course, and today we will discuss about scalar and vector, and this will be our first topic. Second topic will be fixed array and packed array is also related to this concept, therefore we will take this at last of the video. Okay, without any delay, let's start. The term scalar mean in our SystemVerilog encoding the data object which does not have specific range of any data type is scalar. This statement means if in any data type we have declared variable without any range, we are calling that as scalar. This type of thing is our scalar. And the vector is our data object which has specific range for bit, logic and range, and it is called vector. Now one another thing, as you can see, if you have seen this 5:0, this is called big endian, and if we write 0:5, this is called little endian. In this, MSB is here, LSB is here. In this, MSB is here, LSB is here. If you are using this format, then use this format throughout the code. If you are using this format, then you use throughout this code. Okay, so it is very important, because if you are writing number 100 as a big endian, let's say, and if you are seeing in testbench as a little endian, so these both number are same, just it is written in little endian and this is written as big endian. In scoreboard, these two will not match. Okay, use only one type of format, either big endian or either little endian. Okay, so what I have told you, that vector also has direction as little endian and big endian in our SystemVerilog. Vector has direction as well as a specific range. Now let's move forward. If you have understand these two things, then we can move towards our fixed array concept. Fixed array or fixed size array in SystemVerilog, its name suggests that its size will be fixed. Okay, so array size is fixed throughout the simulation, means you cannot change this size. Okay, when you have declared, if it is a 2-bit array, a equal to 2:0, so it is 3-bit array, so it will be 3-bit throughout the simulation. Also its space, like logic, if you have written, so whatever data type has your storage size, okay, that will be also same. Another thing, its value will be initialized as 0. What does this mean? If you have initialized this logic a 2:0 and you haven't declared initial block, and a you have given some value here, okay, let's say for now value, so if you haven't given value, to up till now a's value will be 0000, 3-bit, and after you have declared value, then whatever value will be there, then this value will be here. Okay, whatever value you will give, it will be stored at a variable. Okay? Now this is related to this initialization. Okay? Now what are the types of array you can see in your fixed array? SystemVerilog, your fixed array can be of 1D, 2D, 3D. Let's say 1D array first. Let's see 1D. So I will also write the code for this one. Module, let's say fixed, and here we are using testbench kind of syntax, because we are not creating a RTL for now. So logic, let's say a, and I have given it 1:0, means our 2-bit. This is our variable and we have declared array, and this one is 1D array declared. Okay, now initialize, initial block, so initial begin. There are two ways you can give value to a. First is a common method, that is a0, you can give 1, and another method is, I will change the pane. Okay, another method for this is, you can just directly give a and the curly brackets tick, then if it is 2-bit, then you can give like this, tick 0, comma, tick 1. Okay, like this you can give values. And after this thing, you can also use $display for getting this in your terminal. Display A. Now if you want to see whole array, you can use %p. If you want to see the single values like 1 or 0, you can use d, h, whatever you want for specifying. But p is for array, you can print whole array with the p. Okay, and A. So this is end module. This is 1D array. Now let's move towards our 2D array. So one thing again, how this 1D array will look, it will look like this. Okay, 0 and 1, something like this. You all know this. Okay, now our 2D array. So again we will write module fixed. Now logic. Our 2D array will be like this: 1:0, 1:0, same thing we will say. Now this one is our 2D array declaration. Now we will write initial block again, initial begin. Similar, you can write 0 and 0 like this also. You can give value 1, or you can write A, and in curly brackets you can declare value. Now 0, 1, and this is curly bracket. Okay, and 0, 1. Here there will be no yeah. And as always you can print with $display. A equal to %. One another method is there for printing. I will show in your code, but for now you can use this one, which is mostly used, and module. Now let's see the 3D array. So module fixed logic. You can use any other data type as well. I have a habit of using logic. This is 3D array. Oh, I have written with this one only. Okay, so A equal to, you can use this one. Okay, whatever you seem fit. Then again, see, this one is one block, so means there are 2 inside this one, means 3 inside this one. And how you can write this one is like A2. First is this block, second is for this one, and third I will again make one. Okay, so like this, 1, 0 and comma 1, 0. Okay, and another you can write 0, 0, 0. So these are 2 methods, and again you can write your display same. Okay, so I think you have got the rough idea what you can do with fixed array. Packed array, a very important concept, I would say. Okay, so what does this packed array and why it is important? Okay, so first point is it has fixed size. Second, memory location is continuous. What does this point mean? You already understand this, means we will using fixed array concept for packed array as well. Okay, now second thing is memory location is continuous. So if you have declared array, so inside your SystemVerilog there may be a memory this size, but you have already declared 2 bit 0 and 1. But in next array you also declared another bit. Okay, 2 and 3. So this location will be continue 1, 0, 1 1 whatever. So this location will be continuous in your hardware, and if you haven't declared any variable, it will be like this, means x or 0 will be there. So continuous memory location will be there whether your array is increased or not. Okay, now I will also give an example for that. For example, if you have written logic 0:1 a.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So this is first of all packed array. You have to write on left side. So this is packed array declaration. Okay, this is CLL. Okay, now how the memory location is continuous, now we will see. So for example, this is memory size 32-bit, say for example 32-bit. Okay, now you have declared 2-bit array, so 0 1 here, and you have given value, let's say 2 2. You cannot store 2 in 1 bit, but let's say 2 2. Now you have declared another 2D array of our packed array. Now another location also will be continued from here, like 0 1. So it will be again, let's say you have 1 1 here stored. If you have declared another, then also it will be continued from here 0 1. Okay, it will be 1 1 for example. So and another location will be accessed. So this type of thing happen in your packed array, and I have already explained you this is our 3D array. Okay, so fixed array concept you can create with 3D array. Now third point for packed array is you have a declaration, a special declaration, like you can declare like this 3 tick b0, this single. So this is only possible in your packed array. Another declaration also, because memory location is continuous, so you can give value at one time, tick b0. You can give any because memory location is continuous, right? So you can give value like this, but in unpacked array you cannot give this one. Okay, so it has to be packed array. All the vector quantity should have written on this side only, if you want to understand in simple terms. So this is the logic. Now our next topic is unpacked array. Unpacked array, first point is it is also fixed size. Second means it will follow the fixed array. Okay, now second thing is its memory location is not continuous. Is not continuous. Now what does I mean by this? So first of all, I will also explain this with example. If A is array, okay, so I will explain with this example. Logic A. Now how we declared our unpacked array is here. We declare right side of our variable the size of array. Okay, now this is our memory, and you have declared 1:0. So 1 1 will stored here. This is first memory location. Okay, first memory location. Now if you have declared 1:0, another means 2 arrays of this. So second array will be here 0 1. Now if you have declared third one, another location. It is not consistent with this location. Okay, location can be anywhere in your memory, because memory is a hardware. Okay, we are writing code. If in software it may have stored at a continuous, but in hardware, for example, this is our stack memory. Okay, so what is the concept for stack? We are stacking, and it will just go first come FIFO kind of thing, first come first out, first in first out. Okay, in queue you can say it is like this, it will go inside. So any type of you can do. This is software concept. Okay, you can also create a memory for this one, but there is heap memory also, right? There is also a heap memory where there is multiple locations. If you want to imagine, there are multiple locations here, 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 anywhere. So this is unpacked array. It will store here, 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 and memory location can be 3D or something. The hexagonal code like this is location, and some pointer is there. Okay, so if you want to get the location of this packed array, it is stored internally, whatever location is there, and you will use this pointer to point that location. So this pointer will point this location and give you the value this location, then you give you the value. But what you have declared, like this. So this is stored here, this one is stored here. Okay, so you cannot get where the location of unpacked array is internally, but in your code you will write $display, and in terminal you will get the values of these three. It is internal functioning. Okay, but in packed array location will be like this. It will be continuous location. It will be stored continuously. Rest of the concepts are same for packed and unpacked array. For example, this is unpacked array. And you can also use this kind of method for packed array and unpacked array both, for storing the data 0, let's say. And also you can use this method, like this bracket method, which I have told you previously. But in packed array you cannot store like this, because memory location is not continuous. Okay, the 3 tick D, you can say 1. You cannot store like this because location is not continuous. Okay, it is not continuous, it is like somewhere else. So for example, if value let's say 4, it is 100. So in continuous location you can say 001 will be stored in packed array, but in unpacked array 0 will be stored another place, 1 will be storing in another place, and 0 will be storing in another place. So this cannot be continuous. Okay, it may be 001, it may have stored like this. So you cannot store values like this type of thing in unpacked array. Okay, so this is not applicable for unpacked array. This so here is packed and here is unpacked. So let's say 1D array. In packed array you have declared like this 1:0A. In unpacked array you have declared like this. In packed array you can declare like this, it is 2D array. In unpacked array you have declared like this, 3D array. So you have declared like this. Okay, now can we declare these two type of concept in hybrid form? Yes. So there is also one hybrid array or mixed array, whatever you want to say. So if A is like this, 1 tick 0, 1 tick 0, so it is mixed of packed and unpacked array. Okay, so it will look like this. Okay, if you again increase this one, so it will look like this. If you again increase this one, so it will look like this. Everyone will have its location 0 1 1 0 0 1 1 0. Okay, 1 0. So here is 0 1 0 1 1 0 1 0, and you can give value like 0 0 0 0. So it is a very large concept, but I will give a shortcut how you can find the location. So if here is A, so here is number of packed unpacked array. Okay, and here is our depth, and here is number of packed array. Okay, and here is width. Okay, so for example, if this value is 3, this value is 2, and this value is 1, and this value is 1. Okay, so number of array is 3, you can say, and 3 arrays are there like this. Okay, 3 arrays are there, all of 2 bit, and number of this array is 1. Okay, so this is 1. Okay, this is one line. Now if it is 2, then it will be doubled. Okay, I will it will be doubled. Okay, if it will be 2, let's say it is 2. Okay, and depth is 1, so this depth is 1, this is 1. If depth is 2, if this depth is 2, then it will go like this. So we will have backside of it. Okay, so for example, this is one frame, and if depth is 2, then we will have another frame, so it will be looking like this. Okay, so here are our 1, 2, 3, and there is 2 location, and similarly here we will also have, so it will be having 0, 1, and this is the numbers. Okay, so I hope you have visualized this thing, so you can get the location with the help of this. And how we will get the location? For example, 0, 0, 0. So this one is the first block, so 0, 0, 0 will be this 0, 0, 0. If 0, 0, this one is 1. Okay, so it will be backside of this. Okay, the location will be backside. So this location, if I say the back of this one, exactly back of this one, it will be 0, 0, 0, 1. Okay, so you can understand with the help of this formula, you can say. Now I will show you written code for all of them. So array demo, I have written code for packed array. I have declared like this. For mixed array, you can say I have unpacked fixed array, or all fixed array actually, and mixed array. Okay, so you can declare like this. So we have given directly values for packed array. Okay, and for unpacked array we cannot use that method, but because it is the number of locations are more, so we have used for loop, and we are just giving the values for this one, and also writing the display statement. So you can write this type of display statement as well. In array you have given %d, and %d you can print the decimal number. You also have to give the index here also. Okay, this is 2 loop because it is 2D array. 3D array you need 3 loop. Okay, as you can see, these are the location, but the location are like one location is printing. Okay, because we are also giving the location, one location we are giving the numbers. Okay, but what without any index, directly we want to see a whole array, so you have to write %p with the whole array name and unpacked array. Okay, so remember the name unpacked array we are seeing. So you can see unpacked array we have get a whole location of 0, 10, 20. Okay, we are not getting 1, we have get whole array. First it is initialized with 0 because it is fixed array, then we are getting 10 because we are printing first number, then second, then third. In this way your location is also filled, and you will get the whole array if you print like this. Okay, if you will get the bracket here, then you will also get the bracket.
Please Lord, give me a sign, a sign.